Okay, so let's try one that has some stuff that's going on, if you will. So you have a -3, which is here, gives me my a equals -3. My base is 2. There is no right or left because there's no h, or my h is 0. And my k is equal to 2. So before you can start, or before, if there is no h, you're again looking at a vertical asymptote of x equal to 0. It's not moving right or left, okay? So you don't have to deal with any kind of transformations. This thing here says it goes up 2, so you will have a transformation of up 2. Our base doesn't do anything. This here says it is reflected and is vertically stretched by 3. And this is basically reflected, if you will, over the x-axis. So we have it reflected over x and vertically stretched by 3. Okay, so before I did anything, I can just look at that and know what the baseline will look like of log base 2 of x and what has changed. We've done these before with exponentials, so you should be somewhat used to it. Since it is flipped, we know that this one typically looks like this, right? That means if it's flipped, then it's somehow going to look like that. Not quite sure, but that's what it's going to look like. Okay? So, if we think of it, obviously it's negative, so it's going to be negative. Do we still take our baseline point of 0 or 1, 0? We can, but it may change a little bit because of all of these different factors of what's going to be going on now, as far as all of those different pieces, how things are going to adjust, how things are going to work. Okay, our range is not going to change from bottom to top, just like our domain for exponentials was always real. Our range will be that. Since we didn't go right and left, our domain will still be 0 to infinity. It's always going to be on that right hand side. It can't be negative. If this is our regular one, this is going to be what it's going to look like now that it's been flipped. So it will be going from left to right. It will be going down, so it will be a decline. So before I've graphed everything, I can come up with a baseline understanding of all the other questions over here, or you should be able to, given that it's very similar to the exponentials. It's just the inverse of it, okay? So if we were to graph this, if we were to plug in points, if you will, what point would you want to plug in first? For me, I would probably get some idea and understand that whatever I'm going to do is going to be flipped. Going to look like this. It's going to be, each one's going to be basically multiplied by 3 or vertically stretched by 3. And then each point is going to be moving up 2. So if we think about it in these terms, let's pick some easy points that will be easy ones to get along. Let me do a little, let me pick the back of this here, and we'll try some different points. Hopefully you'll be able to see these. Maybe right there you should be able to. So if we have this, right, log base 2 of x plus 2. So let's keep it simple. Let's don't overcomplicate it, okay? So I know that I can plug in with my x equal to 2, right? So if I go -3 log base 2 of 2 plus 2, that right there is simply 1. So now I have -3 of 1 times 1 plus 2. -3 plus 2 is -1. So now I have x equals 2, -1. Hopefully you guys got all of that. There we go. So I can plot that point of 2, -1 into my graph, which would be 2, say 1, 2, negative 1. We could plot that. Now you can do a lot of these very similarly. Obviously, each one is going to be stretched and pulled. Let's just do another one. Let's do something that, again, we can work with, if you will. Let's pick 4. So we'll say negative 3 log base 2 of 4 plus 2. Well, this is negative 3 log base 2 of 2 squared plus 2. Understanding that 2 comes out front, okay? So now I have negative 3 times 2 log base 2 of 2 plus 2. So it's going to take some algebra. Again, it's algebra 2. So this is negative 6, that is 1, and 2, which is negative 6 plus 2 and negative 4. So when I plug in 4 for x, I end up with negative 4 for y. 4 for x, negative 4 for y. So we go back to our graph. 4 for x, negative 4 for y. Okay? Hopefully you can see that. Sorry if I'm jumping around, but it is what it is. Okay. So now I got an idea that it's going to be looking, it's going to look like this. It's going to be basically vertically stretched by this factor of 3. All of these things are getting pulled apart by 3. It has been reflected. That's why it goes from this shape to this shape. And everything's getting moved up too. So you're going to have to do a little bit of algebra just like I did in here. You're just plugging in numbers, going through, and figuring it all out, if you will. So if we plugged in, or if we adapted the whole equation, it may be a little bit more of a challenge. Our baseline point, remember, if we go back to our baseline point of 1, well, this was now being reflected. Then it's being stretched by 3 and now up 2. So basically, we're looking at 1 should be all the way up at 1.5 is what it should be. I think it's 1.5. It's a question. Yeah. Either way, it's going to look like this. I'll do the math a little bit later. It's going to look like that. It's gotten longer because it's vertically stretched. It's got open. It's not quite smashed in. And if I did this, this would be, if I redid all of these, if I solved for it. So we're looking at, let me do it real quick. Negative 2 to the x plus 2. So we'd solve, we'd go to, and then we have to move all that over y. Let me see how I'm doing this here. Y minus 2 equals negative 3 log base 2 of x, which is then y minus 2 or negative 3 log base 2 of x. And that's 2 raised to all of that. 2 raised to y minus 2 over negative 3 equals x. Let me see how all of this is going to work if I plug in negative 4 is negative 6 is 2. Perfect. Okay, so now let's go over to what I did. This might be a little bit of a challenge for many of us, okay? A little bit of a challenge. So now we have y equals, or we're going back to our baseline, what's given. So now I have to get this log by itself before I can raise everything. So I subtracted 2, which is y minus 2. Then I divided by negative 3. So now I have y minus 2 over negative 3 equals log base 2 of x. Then I go 2 of x. 2 is raised to all of that equals x. This is going to be very, very confusing for many of you. However, now, if you plug it into these terms, right? So if I have 2, y minus 2 over negative 3 equals x. I have that, right? There you go. Then, when I plugged in that, remember our points were 2 and negative 1, and 4 and negative 4, right? So, when I plug in negative 1, this is my y, I'd have negative 1 minus 2, which is negative 3. Negative 3 over negative 3 is 1. So 2 raised to the 1 is 2. So that's why I got 2, negative 1. Negative 4. Negative 4 minus 2 is negative 6 over negative 3 is 2. So 2 raised to the 2 would be 4. So if we go back and we want to know when our x equals 2, our x equals 1, what would our y have to be? So now you'd have to kind of mess with it a little bit and say, okay, well, if my x equals 1, basically this would have to equal 0. So my 2 raised to the 0, what would that, how would I get 0 there? How would I get 0 there? That's a very good question. Because my x has to be equal to 1. So I'd have to have 0. So what would make that 0? I would need it to be, what would it need to be? That would have to be 2. Yeah. 1 to the 2. So my y, 2 minus 2 equals 0 over negative 3, which is basically 0. 2 to the 0 equals 1. So my 1, going back to my graph, is it in the picture? Now it is. My graph is at 1, 2, which is like right around in there. It's close. Again, being elevated, that point being elevated. Because it doesn't get stretched or flipped because it's at 0, 1, 0. So it went up 2. Forgot about that. Yeah, that's going to be fun.